Okay, guys. I hope you can see my screen. So let's continue with the next session about Matplotlib, which is amazing. So I liked it very much. I am also learning with you guys. So I learned it in a bits and pieces, but now I have a flow. I know where to start and where to stop, what to talk about and what to not. So I'm enjoying it. Okay, let us talk about Matplotlib. So we have in Python, then we have data visualization. Yes, yes. Okay, guys. Could you also keep an eye on this icon here? This is the icon which tells me that the screen recording is happening. I was not able to track it. If it complains, please let me know through the message. Okay, very well. So let us continue our exploration with data analysis, right? So I was discussing about exploratory and explanatory um, difference between these two. So in this particular notebook about introduction to data visualization, we are going to cover why data visualization is important. We are going to cover Matplotlib basics like line plot, bar plot, pie plot, stack plot, histogram, scatter, subplots. I'm not gonna cover subplots today, not gonna cover stack, but I have most of the items. So we will do subplotting thing tomorrow. Then Seaborn, obviously we will talk about Seaborn a bit, which is very important for statistics. And we will touch some base about that. So we will follow some practical example, and obviously I like learning by doing. Now, why data visualization is important? The first question we should ask ourselves is because it helps us reveal patterns, it helps us reveal trends, it helps us reveal correlations. By just looking at the data, you cannot interpret like how these two quantities are related, right? You cannot relate like if you compare the market size with number of years, like if you are interested in a particular share or stock, then you want to understand like how this stock grew with time, with years, and how it behaved, how it worked well in comparison to other stocks, right? Something like that. So you cannot just do it by just seeing the data itself, so you need to do some data visualization. And the second point is you can communicate your insights clearly. If you have visualized data or data in a visualized manner, you can see it yourself, and you can also tell other people, okay, this is what I want to interpret from it. And then we can also speed up decision making. Again, this is quite simple. Like if you have the clear data in front of you, you can see, okay, this stock did pretty well, and you can get some insight from the data, and you can say, okay, I'm gonna put my money in that particular stock. And last but not the least, you can make data storytelling engaging. Okay, you can make some fancy plots, and you can show, okay, this is the data. For example, like in our orientation session, I put some data like, okay, I have participants who are doing these things, these are the um, occupation, some of them are students, something like that. I put a pie chart there, and also about the nationality I put. So this is something like you want to engage your audience, you want to convey that, okay, this is what I have. Okay, so this is not about showcasing like what I have, it is about how can I present myself better. Okay, so the greatest value of a picture is when it forces us to notice what we never expected to see. So when we do some data visualization, you can look into those details we cannot do when you are just looking at the data, right? So what is the difference between exploratory and explanatory visuals? So first of all, exploratory, uh, if we talk about the aspect which is goal, exploratory are the thing where you find insights, but in the explanatory part you basically also communicate, right? You can communicate your insight to other people. And again, the audience, who is the audience for exploratory data analysis, the audience is a the specially trained professional like data scientists or data analysts, like you can show them some data by just manipulating with your, like playing with your Jupyter notebook, or showing some basic plots. But when we talk about proper demonstration of our work, our analysis to some stakeholders or some public, like your boss, let us say, then you have to make it very nice, very visually appealing, not a single piece of like technical language, technical technical like you don't want to bore them with all those technical stuff. You just want to tell them like they are a layman and you want to show your stuff. Then the style, exploratory is raw, fast, and flexible. Like if you want to do some data analysis, it is always tedious to plot them. So if I wanted to talk to my boss that okay, I'm doing some neutron star stuff and I'm calculating the equation of state, I am playing with my code and showing them right away that this is what I am getting. Okay, rough. Now my plots are not properly labeled, not indexed, all those things. This is a very rough plot, right? But it is raw, it is fast, it is flexible. I can also show the data to them right in without making them visually appearing, without plotting them. But in the explanatory case, we have to polish it. We have to think about every little detail the plot can show. We have to think about the color, we have to think about the font size, we have to think about the grades. Everything in your data plotting, everything in your plot should be very visible, very clear. Okay, so for to make that happen, we have Matplotlib. Okay, Matplotlib is a library in Python which helps you plot the data, right? So far NumPy, pandas, and then now we have Matplotlib. So this is the last very essential library we are gonna discuss, and which is particularly needed for our data analysis when we talk about physics, right? So matplotlib.pyplot is a module in Matplotlib which is a paintbrush for your data, so you can put visual to your data. So how do we import it? Obviously from the library Matplotlib you are importing a particular feature pyplot, and you are importing it as plot, plt, not even plot. So again it is an alias, you just have to write something which is shorter. So how do I plot? It is very simple. So you get some function, some feature of from plt which is plot. And how do I plot? I am basically plotting a list. So how does plot interpret a list? Is this is x and this is y. This is the first term, first list is x column and the second list is y column. Okay, and when I write plt.show, it basically plot that data. So it automatically assign this thing, first thing to the x-axis and the second thing is the y-axis. Okay, so there is a one-to-one relationship, that's why it is a straight line. Now plt.show, what does that do? If we have plt.show muted, it will not show, but that doesn't work in Jupyter. Jupyter always loads the show automatically, right? Jupyter notebook or maybe Google, any sort of notebook, like any sort of um, interface you are using, you are opening your Jupyter notebook with. So whether it is VS Code, your Jupyter notebook, or Google Research Collab, it is going to show you it by default. It doesn't matter whether you mute it or not. Okay, so this is one thing you have to remember. But when you are doing plot under, like we are dealing with the simple Python script, then it matters. For example, you have to trust me for now that I'm gonna execute this code, and I execute this code, it rendered this. Okay, you don't have to care about what it is displaying. I just wanted to show you one thing. Okay, I did mute, come on, what did happen? I did mute this. Okay, and after muting this I did press the run button, and when I press the run button, it is not showing anything, right? Why it is not showing anything? Because I have muted this plt.show, so it will not display anything. So this is the thing, it works with the simple Python script but not in the Jupyter notebook. Yes, now coming back to my Matplotlib, I don't want that. Yes, so this was about plotting, and then simple plot, and then we have plotting with label and grid, right? So whenever we are writing something, we are plotting something, we need to put some labels, right? We need to put some grid so that our plot looks good, like it is visually appealing, and also we can interpret data easily. We don't have to put much effort in our brain, okay, this thing has to be, done. You don't have to, it should be self-explanatory. For example, in this case, what we have done, so we have created a list, years, then market size. So there are two lists. So before that, what we did, we define the list here, right, within the plot function. But here we have defined two lists separately, and then we put first list as x-axis and the second as a y-axis, so by default x and y. Then we put label, like what I want to call my x label, what do I want to call my y label, how do I wanna print it. Then I title, and then I want to put grid, then this title layout thing. So let us plot that. You can see the title is appearing, right, and there is a x axis label, and this is a y axis label. And what is the grid here? Grid is this thing, you can see grids here, right, this thing. So these are the grids. And why does it happen? Because of this thing here, true. If you put false here, then it will not show. And then we have this very important statement, which is plt.tight underscore layout, which is by default, and it makes sure that no entry like your title, label, grid or something, they are not overlapping, like title is not overlapping with label and vice versa, right? So it makes sure that there are no overlaps, but it doesn't always work perfectly, but it tries to. Okay, so this is about how you plot. And I wanted to also emphasize one thing here. There are two ways you can display your plot. One is like in Jupyter Notebook, you can just see it here, okay. um, and you can also save it as JPG, or you can also save it as PDF. But when you are displaying it here, you can interact with the plot as well, not in the Jupyter Notebook, but in this case. So I'm gonna talk about that when I will talk about this particular Python script. So far this is what we are seeing. So this is like an image. I cannot interact with this plot. See, I cannot, I'm moving my cursor, but it is not highlighting anything, so I cannot interact with my plot. So what next? So can I change the color, can I change the marker, can I change the line style? Which is very simple, you can do it. This is all about visualization. So again, I started with three different lists, okay, and then I plotted, okay, and I plotted one line where I put this years as the x-axis, then smartphone market as y-axis. Then I labeled it. Why I labeled it, I will tell you when I am showing the plot. Then I defined a color, then I defined a marker, then I defined a line style. Okay, so let me just mute that. And then we have x label, y label, title, grid, legend, tight layout, show. So let me just print that. So when I do that, you can see title, all those things we already discussed. The new thing which I have put here is the color and line style. So there are three different things. One is color is blue, and the line style is dotted, dashed, not dotted. And then what else? Then there is a scatter plot as well. So what is the scatter? This is not exactly a scatter plot, it is a mixed plot, but the marker is here, circle, filled circle. So how do I define the filled circle? Is like O within the quotes, right? Now I want to display another line on top of it, on top of this plot. So I will just copy and paste a similar. I will just replace my y array, y list, and I will label it accordingly. Okay, so what are the labels? Basically, labels are the thing which tells us about which lines belong to what. So I will also differentiate the color, marker and line style. So when I do that, I rerun it, I can see, okay, there is another line with these specific feature. Why it has some specific feature? Because of it has orange marker is different, color is different, line style is different. And then I also added this plot.legend. If I mute this, what will happen? It is not showing any legends here, okay. So it is very important, if you want to show some legend, it is very important you do plot.plt.legend, and make sure you have defined labels. If you have defined labels, then it will show them here, otherwise it will just display the colors. Okay, so this is one thing. Now I want my plot to display only markers, not lines. So what I will do, I will just mute it. Instead of writing here plot, I will write scatter here, and when I write scatter, I don't need line style. Okay, so when I don't need line style, so you can see it is appearing without any line, it is just appearing like a dot, only the data points where it is. Okay, so it is very important. So this is how you do it. Okay, let me just copy it so that I create a new for scatter. Come on. Okay, okay, so this is scatter plot and this was our normal plot. Now if I don't want to do show marker, I can just remove marker, right? Sometimes I just want to show lines, which is good. Okay, and if you do not specify a color, Python will choose by itself, right? If you want to specify, you can choose any color, you can create a combination, you can put any hexacode, or you can put any RGB combination. So we will discuss about that later on. And about markers and line style, like there are different line style, there are different markers, you can also make custom markers and line style. So you can just simply do a Google search, what are the different line styles, and you can put it accordingly, right? I'm not gonna uh, spend our time discussing those. Okay, so far so good. Now this was a scatter plot, we already discussed. Then we have different plot style available. It is like a theme. So in our mobile we have like different themes, in our computer we have different themes. So just make it visually appealing. So so there, if so here I am printing plot plt.style available. So these are the style, different style available, right? You can select any of them. So I have used selected ggplot. When I do that, I am not specifying any color, so I am using my same arrays as previous, and I am just defining labels, and by default from this style it is using the colors, right? So it is displaying something. So you can choose any of these style and you can make your plot look good, right? And plots also look good when you put efforts in the width of the line style, like does it look good, what are the color combination that goes with together. So these are the some um, artistic viewpoint that somebody can have, like they can make their plot more look more good, right? So I'm not gonna talk about that. Then we have numpy and pandas together, right? So in numpys and panda together, we can also use it, which is very simple. If I want to do some numerical calculation, I call numpy whenever I need it. Okay, so how do I do it? So I imported numpy as np, imported matplotlib.pyplot as plt, and then I started a loop. What I wanted to do is I am creating. Okay, let us start with the end goal. It is easier. So what I am doing is here, x-axis is a number from 0 to 100 and y-axis is a number from 0 to 1. So what I'm creating is here, I am creating in the x-axis from 0 to 100, I am creating random numbers which should be between 0 to 100, random numbers which should be between 0 to 1. So how I am doing it? See, using this np.random.rand function. What does it do? This np.random.rand function, it creates 100 random values between 0 and 1. 0 and 1 is by default. So basically what it is doing, for each time I am running my loop, like I am running my loop for how many times, 50 times. Range is 50, that means 0 to 49. Okay, for zeroth iteration, it extracted, it gave me some random numbers. Okay, from 100 random numbers from 0 to 1. Okay, 0 0.1, 0 0.2, 0 0.3, 0 0.05, whatever. And the line width I have defined for this plot. So every time this, for this iteration, this statement is executing, so we are getting like 50 different lists, and for 50 different lists the plt.plot is plotting the plots here. So there are 50 different plots here. Okay, and it is automatically choosing colors, line style for different plots. I have only specified the line width. And then we can also specify in np.random dot, if you want to generate some random number. I don't want to only generate with 0 and 1, which is the default option, but I want to do it for something else. Like I want to specify start from 10 and at 50, and give me 100 random numbers between 10 and 50. Okay, so it will give you that. So with the help of this random number, you can design a game, guessing game. For example, okay, you can design a game, uh, some string logic you can put, you can design a game. Okay, user give you some entry, the whether user guess the values right or wrong. You can do that. So like you created some program, you are asking user to guess whether it is a even number or not, right? And then you are using this random function, which is very easy, trivial. Okay, so this is how you use NumPy and Matplotlib together. You can put your NumPy stuff here. You can also declare it somewhere else. Like you first create your list outside the plot thing, and then you put that list in the plot. Okay, so that is also doable. Okay, what else? Bar plots. Bar plots are good, and there is another way of looking at the data. So this is the same data but in the bar plots. So just have to write plt dot bar x and y, and you put everything, it will display you the bar chart. And if you want to do some fancy thing, you can just rotate your x ticks, which are the ticks here. These are the ticks, and these are the corresponding label ticks, and you can rotate it 45 degree or 90 degree, whatever you want. Okay, which is simple. Then bar plot with multiple bars, this doesn't look good, there is no comparison going on. So what we have to do, we have to plot multiple data. So how we can do, we can start with a list years, then smartphone market, power bank market, again a simple example. And now I added a fourth one, which is earphone market. Okay, so these are just a number, they are not particular research, random number, random stuff, just to show you. Then what I did, I plotted the first data, like with x-axis as year. What is, you can see axis, what I have put years into x-axis, which is a variable. And then smartphone market is the y thing, and then width of the bar, what width I am interested in, which is the feature of this dot bar. And then I did the same thing for power bank underscore market data and earphone underscore market data. And then I plotted the ticks for x-axis, x label. I did all those things we already know. So when I run that, so I can see this beautiful plot where I can compare the data, right? I can compare between three different uh, market size. Okay, so market size in billion US dollar with respect to year. So we can easily conclude that the sale of the smartphone has been skyrocketed in comparison to power bank and earphone. They are also skyrocketing in comparison to themselves only, but the smartphones are selling very fast. So this is the interpretation which this data can give us. So if we just look at the data itself, it is boring, right? I don't want to see numbers, I don't want to draw conclusion from numbers. But if I have a data in front of me, I can simply look at it and I can easily tell anybody, any layman person, okay, this is what the plot is telling us about. And you can play with colors, you can play with font size, you can play with font family, okay, font style. This is up to you how you can improve. You can also improve the final output of the plot, which doesn't look good right now, but you can improve it. What else I wanted to tell you, there is a this thing x minus width and x plus width. There is a purpose of doing it. Why? Because if we don't do it, so the plots will just overlap. So it is not comparing, it is not, visually appealing. So to do that, we do some, computer trick. So we manually define a variable 0.25, and we pushed our x-axis for some particular case like smartphone market to the left, and pushed our x-axis for the particular earphone market right, so that when I run my code, the interpretation of the data is same, but I can see it can compare it good. Okay, so this is one thing. And then we have horizontal bar plot. So it's also easy, it is very simple. We have list, then we have again a list, and within a list you can also do mathematical calculations, right? So when you do that, you just use plt dot bar horizontal. So the only difference is this is a horizontal bar plot, like we were doing vertical, that this is horizontal. So wherever you need it, you can do it. The only difference is this bar edge. Here what it was, bar. Okay, then we have pie plot. Pie plot is also very useful, very illustrative when we want to compare some different things. So pie plot, pie plot is looks something like that. Okay, so how do I do it? We have labels, we have again a list of strings, list of numbers. Now what I do, plt dot pie, my x-axis, my y-axis. I don't have to provide x-axis, y-axis because this is a pie plot. So I just have to provide one thing. I provided one axis here, and labels, I defined it as labels. So it associate a particular market share with the label automatically. 182 Apple, 222 Samsung, as long as the dimension of both the lists are same. If the dimension of one of the list is different, it will complain. Okay, and then we have this auto percentage option or feature in pie plot, which is like if you want to create auto percentage for your pie chart, you can do that. If I remove that, let us see what will happen. If I remove that, it is not displaying any percentage, and if I do add it, it is displaying, it will display. And if I do 1.1, 1.4, it will display some significant digits after the dot. Okay, it is up to me, how I can play with the pie chart. So this is simple, just one line thing, right? You don't have to code extensively, and you can choose colors as well. Now it is choosing by default. You can write colors. Oh, I have GitHub Copilot. Okay, what you can do, colors, okay, then equal to, then this, then you can write, okay, give me blue, green, whatever. Okay, give me all those things. So I am just going, okay, so I do this, and then I write, okay, colors equal to colors. Okay, so when I do that, I run my code, it will show me that colors. So it is up to you how you can wanna play with it. Okay, so how many we have? Just 3 or 4 code snippets. Then we have custom color and custom pie chart. Oh, I already told you about it. Okay, so custom color and custom pie chart, let us see about it. So I will just run it, it is easier if we can relate it. So you can see this is a nice pie chart, improved. It has some other feature that looks visually appealing. For example, you can see there are some outer lines which is dashed. Then we have some shadow, right? So it looks good. and it has this visually appealing thing which the slice is somewhat out. So how do I do it? So you can do it using explode. If you want to explode first slice, you can just write 0.1. If you want to explode it more, you can write 0.234, whatever. It is a coding thing, you can play with it. Then what is the next thing we are interested in? Colors I already discussed. Explode is the array that we have created here, and we can associate the number. And if you want to explode something else, okay, let us explode the second entry. Okay, it has been exploded, but it doesn't look good. Okay, let us put it back. Now uh, what is the usage of explode? It makes the apple or a particular item stand out. Then shadow is true. This is the shadow, you can see it is because of this shadow feature. And then star angle. Okay, where do you want to start? So let us see 45, and when I say 45, I run it. It basically orient it, right? So you can play with it, and you can make it wherever you like. Auto percentage we already discussed. Then this is the wedge props helps us control the some features. For example, the outer wedge. So this is a wedge. Okay, wedge or edge. What is the edge color? Okay, it is black. What is the line width? 2. What is the line style? Dash dash. So you can play with that. Okay, line style dot, line style 1. No, I don't want black. I want, what color should stand out? Dark blue. Is dark blue a color in Python? Okay, okay, it looks better to me. So you can manipulate, right? You can do this thing. And then we have histogram. Okay, histogram is mainly used in experimental particle physics. Okay, so it looks like that. So the difference between bar chart and histogram. So this is simple, guys. You can just write plt.hist, whatever you want to display. Then the bins you already defined as an array, and there are random number. Using randint we have used we have created the list for variable ages. Okay, like give me 100 random numbers between 10 to 50 random integers, and you printed it. And then there is a new thing, alpha, which is new actually. So what does alpha does? Alpha create the opacity or transparency. If I do alpha 1, it can be associated with any property, right? So if I do that, you can see the grid it has become darker, right? And if I do alpha is equal to 0.2, now it will be faded. Okay, so 0.5 was the good choice. Okay, similarly you can control your you can apply alpha to anything, like your color, your line style, your color basically, and then you can control the intensity of that color. Okay, and so whatever property you want to assess of a particular method, you can just change it inside their argument, right? So this belong to grid, that's why it is changing grid. So what is the difference between histogram and bar plot? You guys can read. I just put it here so that whenever you go to the Jupyter notebook, you know the difference. Okay, now can I save this plot as PNG? Can I save this plot as PDF so that I can access it later on, or so that I can put it in my LaTeX document? Can I do that? Yes, obviously you can do that, right? So one way is, so you are familiar with this, right? You are an expert now. Now what new thing I have added in this particular code snippet is this line. So this plt.savefigure bracket round bracket, and this is the path with file name. Okay, whatever I wanted to give, whatever I am saving, and these are the pixel per inch, right? DPI. So how many DPIs, how many pixel I want in that particular image. That if you want, your image to look good, more visually appealing, then you should increase, but it will also increase the uh, memory of that particular image, like how much memory it is acquiring. So DPI 300 is a good resolution. Okay, so let us do that. Let us do without it. So I ran it. Okay, so it is just displaying it here, it is not saved anywhere. Let me delete my previous plots, otherwise you will say I'm cheating. Okay. So I ran it. Okay, so you cannot see any image here, right? So one way in Python Jupyter notebook is that you can click this button, you can save it manually, right, wherever you want to save it. And the other way is you write this line, and when you write this line you run it, and when you run it, then you can see there is a figure. Okay, I have already saved it. This looks good to me, I like this plot. Okay, so you can increase, you can play with DPI, you can do all sort of stuff, you can explore if there are any other options. You can play with BB box inches tight. Okay, when you are using BB box inches tight, it is a very important property. It will trim all the unnecessary part from your images. For example, if there is a white space here in your plot and you don't need it, this is the property you have to use. And when you use that, right now I don't have it, when I will do the sub figure thing, then it will be more displayed, but right now I don't have it. So bb box underscore inches will do what? If there is a white space in the document which is not needed, it will just trim it. Okay, then save uh, without the white space. So this is how we can save our plot. Okay, and then what is this? Plotting using pandas and saving as PDF. Now, so far we have not discussed pandas, right? We were only discussing Matplotlib, but can we combine them? It is easy. You can combine NumPy with pandas. Very simple. It is. It depends upon our use cases. You can also also use pandas with Matplotlib. It is just like how you are. So Matplotlib needs what? It needs data. You can give it as a list. You can give it as a file, right? If you are giving it as a list, you need NumPy to play with the data. If you are not giving it as a list, then you need to have a pandas. Okay, so let's start with pandas. You created a dictionary again with some key values and keys, and then you created it, converted into a data frame. Then you are plotting it. How are you plotting it? There are several ways, right? So you are plotting a data frame df.plot, and x is the year, y is this. So you can define two y columns in just one line in Matplotlib. And what is the kind of the plot line? Marker is this, line style is this, and I also defined figure size this time. So these are the things we already know. Okay, and in legend you can also define the category. So when you do that, at last you have this plt.savefigure, and this time I choose PDF, and I declare the format is PDF and DPI is this. When I do that, when I run that, this is the plot it has generated, right? And it has this category which is because of this thing. If I don't put this guy here, it will just plot the legend, but it will not show the category. Sometimes I do need it. Okay, and I also I think control the yeah, I can also do that. So there are several options, right? You just have to explore. Alpha is 0.7. Okay, when I do that, oh, it is complaining. Why? Legend in alpha, it is not reading alpha. Okay, you can do font size, you can do, I do font size, I remember. Title, font size, you can play with these things. Okay, so there is one important thing, guys, like we need to put this habit, like whenever there is an error. Okay, errors are inevitable. So I do alpha 0.8, right? Now it started complaining. I got to know that the argument alpha in the init constructor, it is not taking it as an argument inside the legend property, right? So it is not compatible with that, so I will not put that here. So I will think about something else. Okay, so this is how I got my plot, and I saved it as PDF. You can see it here, it has appeared here. So it looks fabulous. Now this DPI 300 is very good, right? You can import it in your LaTeX. What else? So I have just three more examples left. Plotting from file using pandas. Now this time what we will do, we will not define list in the code snippet itself. We will extract, we will get it from outside, like from some output file, and we will load it using pandas. We already discussed, right? And instead of rest of the code is same, right? You are executing it as the same thing. So this is one way, okay? And then the data was same, you have to believe me. Then this time I want to emphasize one more thing, that you loaded a data file and you specified a delimiter. You can also rename your columns name. For example, this is data market CSV. Let us display it side by side. Come on. Okay, so this is data market CSV. Yeah, so there is a name of the column your smartphone power bank, right, on the top. And basically what you are doing is, sometimes we don't need to put efforts, like I don't have to remember what is the column name, what is, if there is a header or not. Sometimes in your in your output file, whenever you generate from the code itself, you don't care about putting a name there, because sometimes it confuses. We don't remember to skip rows, we don't remember to skip headers. So in that case, um, uh, we don't have to remember the column names. So what we can do, we can rename the existing column with name with the some meaningful things. For example, I have renamed it, so it extracted the first column and I renamed it with this year. So it doesn't matter whatever it's written here, it will change it to that. And later on I can call those column using data frames. So naming, labeling the columns are very important in data frame in pandas, because this is how you will manipulate your data. This is how you will use your data again and again, right? So so this is the simple case. I don't think there is anything fancy other than this line. Okay, and the last thing I wanted to tell you about, skipping rows. So as I was discussing, that this is redundant. When I am manipulating my data, this first row is redundant, I don't need it. It is just to show me that, okay, what is the meaning of first column, second column, third column, and it will not help me while running the code. But if I am doing some numerics, if I am doing some numpy calculations, it will complain, because you cannot add a string to a number, right? You cannot add year to 1990, so it will complain. So in that case, what I will do, I will tell my code that skip first row. I don't care about header, I don't care about the first row. So this is how you can do it. You can just skip row 1 and you can just write header is none. You can try playing with this command and you will get to know, when you do that, uh, your panda doesn't care about. Okay, let us print and see. Now it will not display. This is the problem with Jupyter Notebook. Okay, I know what to do. It doesn't work with that either way. Okay, now it worked. I have to mute some statements, some unrelated, meaningless statements. Okay, anyhow, what I wanted to say is if I do skip rows 1, then it basically skip the first row. If I don't do that, if I just write skip 0, then what will it do? It will do is it will also print this, which is not meaningful when we were doing numerics, right? So it is good if I do a skip row. Now let us do one by one this thing here. Okay, this the idea is same what we are doing. So actually I use this in my codes. So I define my columns. Okay, I redefine my columns in some way, and I can also define my columns by using name function here, right? So there is no need, if we already discussed it here, there is no need, I can just skip it. I just wanted to show you how skip rows work, and I can also write skip rows here. Okay, so if we are, since we are loading the data again, right? So I don't need it also. So when I do that, I can see the plot is working. Hope Matplotlib session is being recorded. Yeah, it is being recorded. I am almost done. It is remarkable. It is very good. Uh, yes. What else? Yeah, that was so far about Matplotlib, and I also wanted to emphasize on this codes um, .py. See, this is the same plot with list. I'm not using any data frame here, pandas, but I wanted to show you something else. That's why I created a different file. See, now I'm not showing plot.show. I did that, now I will do. So when I do that, it is showing a plot. Now the difference between when you execute it from the terminal, right, it will show it something like that every time you execute it, right? Every time you execute it, it show you something like that. But this is opening in an interactive panel, right? In this interactive panel, you have like certain tools. You can zoom in to your data point, which is very important, like you sometimes you need that, and you can go right, go left, okay, go left, or whatever steps you have taken, you can go back and forth with that, and then you can come to the basic, and you can also fine tune it. You can choose your, basically this is an interactive window. You can work with these things, and when you are done with your settings, you can just save it, right? So this is one way. I do not save it using this interactive system because this is time consuming. Once you have made your canvas with all the margins within the code itself, you check, then you just do it. Okay, so this is how you can interact with it. You cannot interact with your plot when you are working with Jupyter notebook, it doesn't allow you, but when you are working here, it allows you. Okay, sometimes you don't want to, for example, you are in front of your supervisor and you are showing him or her some data analysis, right? So you cannot zoom in into a figure. You can zoom in, but it doesn't look good. Also, if you are doing that, you can also put your cursor here, and you can say on the bottom here in this side, you can see, okay, what is the value? The value of x is this, y is this. So these are the things which you can get from interactive window, but not from the figure itself, right? So this is important. And one more thing I would like to tell you about, if your Linux terminal is not embedded well with your main operating system, then it will not work, because then the Linux terminal will get a hard time to talk to your computer, because it is running in somewhere else. It is running it as a disk operating system or a non-graphical user interface system. It will not be able to generate some graphical user interface. For example, if you are running Cywin and if you are using Python in Cywin and you are executing in Python code in Cywin, you will not be able to, Cywin will not be able to display this interactive window. So you always have to go to your folder, save it somewhere, and see whether the figure is looking good or not. Okay, So this is one thing you should notice. I think it should work with WSL or Ubuntu. It will perfectly go well. Okay, so this was so far about Matplotlib, and let me show you some of my code where I can show you a little bit of how I use pandas and all those things, right? Okay. Come on, what did I do? Okay, so you can do as you grow in your code, like you need all those different stuff, right? So don't get intimidated by all these libraries. We are basically using only three libraries so far. So as you need like 3D plots and all those different things, as you are moving forward, you will need all those things, right? So you don't have to worry about that. So this is something different. We don't need it right now. Deciding variables, all those things, we don't need it. So this is what, yeah. So I just wanted to show you this, like how do I load data in my system. So I have some file name with dot hadrons, which is a text file. It doesn't matter what kind of extension it is. It is a text file because it has certain scheme of columns, and I'm reading it as CSV file. Okay, and the delimiter is something fancy, backslash s plus. This is a standardized delimiter when I don't have to care about, okay, I don't care about how many delimiters, what kind of delimiter I have in the file. It can read comma, it can read space, it can read anything if I have this fancy delimiters. Okay, then I have use columns, which tells me how many ranges. I also told you today you can define it as a column, you can also define it as a range. It specifies how many columns I have 16 columns. Then names of columns, like for each column what name I have. Okay, I have defined a different list here, and I just put a list here. Okay, because it is easier, otherwise I have to put everything here. And what is the engine, you can also define it. Engine, it is not needed for now, but in when you are trying like extensive coding, you can do that. And this try and exception is something we will do, talk about that in later sessions. So this is how I load. Okay, and then in when I wanted to plot something, for example I want to plot Mason mean fields, right? So I am creating some lists, and main thing comes here. So I wanted to do, so these are the subplots in plots, so that's why there is AX. Okay, AX is axis. When we locate a particular subplot, axis 0 is this, axis 1 is this, we will talk about that. But the central idea is these are the things you learned today, that you have something plt dot plot, and you can define your variables, you can define your, you can customize your all those things, and then you do all the x label, y label takes, you can control. Okay, so as you grow more in coding, you learn like which stuff is more likely to use, how can I improve my data, right? So I'm not gonna talk about that more. So I guess this was all about my Matplotlib session today. It was about 45 minutes. Okay guys, do you have any questions? Okay, no questions. Let me just stop the recording so that